Hi, I am Virendra and I am presenting a project opportunity for machine learning powered candidate skill assessment. The traditional hiring relies on resumes and interviews. These are manual and often inaccurate. The AI tools enables the candidates to produce better outputs, making traditional assessments less reliable. Machine learning can analyze the structured as well as unstructured data to assess the candidate's proficiency. It enables scalable, fair, and data driven skill evaluation to support better job role matching. This talent assessment market is projected to reach $13.6 billion by 2027. Is there really a problem? Yes. Traditional skill evaluation is manual, slow, and unreliable, especially in high volume or technical hiring. Can machine learning really help? Yes, machine learning can assess skills by learning from test data, code samples, and resumes to predict proficiency levels. Does someone really care? Yes. Recruiters want faster, unbiased hiring, and candidates want fair assessment and better fit roles. As per the CRISP DM business understanding, the problem definition is as follows. The target users are the recruiters, hiring managers, HR, as well as learning and development teams. The problem statement is as follows. It is difficult to consistently and accurately assess real world skills of candidates, especially for technical roles. Why does it matter? Because poor visibility into actual capabilities leads to mismatched hires and long hiring cycles, and in this whole time, losing productivity. Currently, resumes, interviews, manual screening, as well as coding tests are used to assess the candidate's proficiency level. And the gaps, as we have already seen, it is highly subjective, this is not scalable, and it is difficult to detect any AI assisted output, as well as it lacks insight into skill gaps. To define the success, we would first have a look at the impact it has on the business. The business impact is faster, fairer, and higher quality hiring decisions, better job role alignment for the candidates, and increased internal mobility for the employees. The constraints are evolving job definitions, AI augmented outputs, limited label data, and there are fairness concerns as well. So, the outcome matrix that I would like to have here is reduction in time to hire, increase in the quality of hire. This could be tracked by performance rating, post the hire, and hiring manager satisfaction rate. The output matrix for the machine learning model would be skill prediction accuracy, the precision of role match predictions, and volume of actionable insights that have been generated by the model. The additional factors to consider here would be past experience and role history of the candidate, testing the performance and code submissions, resumes, certifications, and projects that the candidate has done, time taken per task, as well as interviewer feedback. The solution concept is as follows. I want to develop a machine learning model to assess the candidate skills using structured data, that is, test scores, certifications, experience, as well as unstructured data, which is resumes and code samples. I want to use classification and regression models to predict the skill levels and skill fit scores for job roles. I also want to incorporate natural language processing for resume parsing and code analysis models. It could be using token complexity, structure, or test coverage as well. So the final output here is a skill profile plus a role fit score to assist hiring teams in decision making. The solution validation would go ahead as follows. In the phase one, we would be creating a baseline model. Here, we will only train initial model using historically labeled skill data and evaluate using the accuracy and the precision on skill classification. For phase two, we would be going into feature refinement phase. Here we would add additional features like AI usage indicators, project completion times, and retrain and compare it against the baseline. Phase three is when we would be testing our model with real world data. Here we'll pilot with real candidate as well as recruiter feedback data and have a recruiter feedback loop. We will compare the predicted skill scores versus what the experts have evaluated. And phase four, which is a continuous learning phase, this is the lifelong phase for the model. And here the model would be fine tuned with the ongoing data. It would regularly retrain to handle drift in skills and the job definitions as well. The system design consideration would be as follows. It would be a cloud based system. Reason being, skill assessment involves processing structured plus unstructured data and may use large NLP code models. Cloud offers the scalability, easier integration with HR platforms, and access to compute intensive resources as well. I would have an offline learning mode here. Reason being, skill definitions and test structures don't change daily. Model can be trained periodically on labeled historical data and retrained with new batches whenever needed. This also ensures stability and avoids overfitting. For prediction, again, I would be choosing a batch prediction mode because assessments are typically triggered during recruitment cycles or internal reviews, and it is not really real time. Batch processing also allows analyzing multiple candidates at once with consistent and interpretable output. So, the overall design here is a cloud based, offline trained batch prediction system which ensures accuracy, scalability, and alignment with real hiring workflows. The potential risks when the model is deployed in the production environment would be as follows. The first for me is data drift. Here, the candidate inputs may shift due to increased use of generative AI tools, and it would impact the model in a way that the predictions may no longer reflect the true skills. To mitigate this, we need to monitor input distribution and retrain on updated candidate behavior. There is also a potential risk of concept drift. Here, the definition of proficiency itself evolves. The impact would be skill labels from past data may lose relevance. And to mitigate this, we need to redefine labels with domain experts and refresh training data periodically. There is also a certain probability of training serving skew, wherein the differences in feature engineering logic between training and production environments do change. The impact here would be inconsistent skill scores and reduced accuracy. To mitigate this, we need to use shared pre-processing code, validate input output during deployment as well. And there is also a very small probability of latency issue. Here, the models may face latency when scoring large batches during peak hiring periods. The impact would be delay in delivering insights into recruiters. And to mitigate this, we need to optimize the inference pipeline, pre-compute scores for high volume predictions. Thank you.